Hi friends, so welcome to another video. This time the video will not be about something new, but it will be more on the debugging. So we are going to debug a code that didn't work in the last video. So let's start. So what is the code? The code which was where we was trying to run all the 4 legs at the same time using basic blocks without using the block provided by Stempedia. This is the block that will anyway do the work. So if you are happy with that, maybe this video may not be for you. But if you want to dig deeper and want to understand that how that really happens in the middle, inside, for that this is the video. So what we did, first of all, let us initialize. So what I am doing, because this Quarky Dog Mini is running in expansion mode, so I click on the green flag to initialize and set everything to 90 degree. So you should see this leg, which is not right now in 90 degree, will switch back to 90 degree, this one, and others are almost in 90 degree. So just observe. Oh, 1 minute, I have to connect, right? Sorry. So this is the board, this is in Bluetooth connection. Refresh. Sorry, I have this installed already, so I should just do a try again and then I should get it. Yeah, I got the sound, so it's working. Connected. Now let me click on the green flag and see the leg is straight up, means this code executed. Expansion board is initialized. Now what we want is, we want to make him work in a way that all the legs should flap at the same time. Okay, that's the agenda. So for that, what we did initially was, this broadcast came later, but before broadcast, the idea, what we saw in the last video, if you have not seen, I just quickly do it. This was the code where you might be more familiar to this. State 2 and state 3, where we was expecting all the wheel to work at the same time, and when we click on the space button to run this in 10 cycle, you see all the legs are not moving at the same time. There is a gap, there's a delay that we don't want. For example, this 2 leg, if you see, they was not moving at the same time. We started one more time and space. Just notice these 2 are not flipping at the same time. There is a delay, so we want to take care of that delay. So that was the agenda. So for that, what we did, we said that forget about the null, because these 2 are the thing we want to move. So we said that we have to send this change signal, that change the angle to 120 or the 60 degree. This signal we have to send parallelly. So this way it is sequential, 1 by 1, but we want to make it parallelly. So that's where we introduced this concept of broadcast. It's in the same sprite, still we are broadcasting. Why? Just to make it parallelized. It will be parallel if we make it broadcast and catch by the same sprite. That was the idea. And then we tried this. Similarly, this is the state 3 broadcast, and then similarly for state 2 also we did the same broadcast. He sent the message, and from 4 threads we catch the message, and hoping they are at the same time, so the broadcast will make it parallel. And then I want to bring all of them in the screen, and we want to debug this, why it didn't work in the last video. So yeah, it didn't work in the last video, and we'll see and debug and make it work. That's the agenda of this video. So debugging is a skill that will make you different from others, where people will be satisfied with a ready-made block and they will not even go into the details and know that why it is really working. So yeah, in support that, let's see. Okay, so this is the new arrangement, where instead of running in sequence, you send a broadcast and everybody in the broadcast will receive at the same time. So if I arrange it this way, this will make more meaning. Just for your understanding, I am arranging it this way just to show that they all are actually going to happen at the same time, supposed to happen at the same time. Okay, so similarly I'll move it here. If I keep it back to back, one down other, you will feel like still it's looks like sequence, but this is not, this is the one. Okay, so now if I click on the green flag already and click on the space, but you see only one leg is moving. But you notice this is the observation. You see all the broadcast blocks are actually executing. It's not like they are not getting the signal. See, they all are getting highlighted at the same time. That means they are executing. And if you are not convinced, I would do this way. I'll just move it out and create a variable. So this is a part of the debugging, don't skip this. And I'll say increment inc inc1 inc2 inc3 and inc4. So what this 4 increment variable will do, initially I will make all of them 0, 1 2 3 and 4. I'll make all of them 0, one extra. Okay, and I will do it at the very beginning. Okay, so now what is the idea? Every broadcast message I will change it by 1. For servo motor 1, I will increase the increment 1, servo motor 2 increment 2, servo motor 3 increment 3 and servo motor 4 increment 4. So the expectation is they all these three incrementer will get same count. So I will run it 10 times, so everybody should get 10. If only one leg is moving, and if you are if you are assuming only one broadcast message is finally getting executed, it will be clarified here. So let's see, green flag and space. See, all the incrementers are moving at the same time. That means the broadcast message are being executed, but finally the legs are not getting the signal. So we drill down the problem into a thin possibility of problem, where we nullified the possibility of broadcast block not working. Broadcast block is working. That's not the problem. Then where is the problem? Now here the imagination or the basic concept is going to help you. So now you understand this point. Okay, so these servo motors are a physical element. They are connected with the Quarky block. They are physical hardware. So when you send a signal from this block through the Wi-Fi or through the UART data cable, they actually comes out as a command, and the command is received by the Quarky, and he will send that to all the 4 legs. So what if, just imagine, just assume, what if only one signal is reaching to Quarky and other 3 signals, even though they are trying to send over Wi-Fi in this case, or I mean Bluetooth in this case, or could be if you connect with data cable, through the data cable, whatever it is, as a UART command, when you are sending 4 commands, probably only one command is finally reaching out to him. Because you are sending all of them at the same time, I assume some clash is happening in the PictoBlox side and they are not able to reach out. So if that hypothesis is correct, how can I prove that? Going with my hypothesis, if this is correct, then if I introduce a small delay between the broadcast, it should start working. So that's the idea. Okay, so what we'll do, we will introduce a small delay. I don't know how much small it is, so let's start with 0.01 second. So the idea is the first servo, he will pass through, but at the same time second servo should not arrive at the UART port. So for that I introduce a delay just before the servo motor, and similarly for the next servo I introduce one more delay, and finally I introduced one more delay. So they are like a step function, or they are in a stepwise. This guy is receiving the message at the very early, and then you will not sense this much. 0.01 means how much? 1 millisecond. That 1 millisecond change you cannot feel, but it's a lot for the UART. And why 1 millisecond? It could be even lesser, but if you see the settings that they are using, Bluetooth settings, they are using where is that? There is a baud rate, and they are actually using the ESP32's default baud rate. So I don't see that number here. It should be somewhere in this list. Change file directory, Bluetooth settings. Should be Bluetooth settings somewhere. There's the port number and about the device installation, coding environment, Python settings, audio video. I'm not sure where it is, but I remember there was a place where you can see it. But anyway, that's not a problem. We know what's the value. I just forgot. It is like 17 something. Okay, so what's the default value of ESP32? That's the one they're using. Okay, leave it. So now, if that is true, then the baud rate is really high. That value is like 6-digit number. So 1 by that 6-digit number means it's already in microsecond. So each bit is actually passing in a microsecond. So if the whole command is actually, suppose say 16 bit, so 16 microsecond. So it's still way, we are using milliseconds, so we are still 100 times slower. So this is acceptable. Even we can go further down, I believe, like 0.1. We'll try that, but let's try with this. So this is the idea. So now with this, if it works for the servo motor, okay, let me introduce it for both the side, then it will be symmetric. So wait 1, wait 2, 1 for this, 2 and 3, 1 2 3. So these two, oh sorry, first one doesn't need anything, or actually they need, because the 4, no sorry, this is the next sequence. They are already in sequence, so they are not clashing with each other. These guys are only clashing. So this one 1 2 and 3, fine. So if this works, then our hypothesis will be proven. So first of all, green flag, ready. Now let's see, if I press the space button, what do you think, what will happen? Let's see. At least we are seeing some of the legs are working instead of not working at all. That means we are in the right track, right? Now let's tweak this number a bit and see if it really starts working. Okay, so for that, first of all, what I will do is this broadcast and wait. Yeah, this is needed, broadcast and wait. So because if you don't give and wait, until they even though they are not finished, it will go to the next state 2, or state 2 will go to state 3, even though they are not done. So this wait will ensure that all these parallel threads are done, and then only it's releasing to state 2 and vice versa. So this is good. And what we'll do is we'll increase the number. So instead of 0.1, I will make it 0.05, and this one I will make it 0.15. So multiple of 0.05, and then this is 20. Similarly, I will make this 0.05. So I haven't tested it, I'm just directly recording, and if it doesn't work, then I have to re-record with some other debugging technique. But yeah, failure is also a learning for us, right? So yeah, I have to finally make it work, and then I will post this video. Hope this will work now, and I can post it this week. Then let's click the space button. So this flag worked once and then it stopped. Which leg is this? Let me check. This is 120. This is the fourth leg. So this is the last leg who is 15 and 15. They both are at the same time. See, this is also proving that we are right, because these two clashed and one of them only reached. Nice, right? And now space. But still it's not working. And so this means it's unpredictable for this time gap. So now if I make it to 10, 20, 30 and 10, 20, 30, green flag, space, now all the legs are moving, but what we wanted to achieve, all the leg will move at the same time, that is not happening. But at least it was not working and now it started working. That means we are actually at least prove that it is clashing somewhere, and that's why it was not working, and now it is at least moving. But now why it is not moving, we have a reason, because we are giving a weight and this weight is too much. 0.3 means 300 millisecond. 300 millisecond we can perceive, we can feel. That's why we are not able to because we can feel, we are not able to satisfied, because it's not moving, it's not serving our purpose. But because it's a debugging class or debugging video, we are good to conclude that there is a throttling, or there is like, if I can draw the image, what I can visualize. So this is what happening. This is our PictoBlox, or say our computer. From the computer, either by UART, the data cable, or by Wi-Fi signal via wave, wirelessly, it is reaching to the Quarky. And Quarky is connected to the Quarky expansion board, and then finally expansion board is connected with the 4 legs. Okay, so leg 1, leg 2, leg 3 and leg 4, all the servo motors. Now when you are sending the command, say you are saying leg 1 move to 60 degree, L60, something like that, and then at the same time L160, then at the same time you are doing L260, at the same time L360 and L460. If you are writing all this thing at the same time, it's a single cable, right? UART is using the single cable for transmitting and single cable for receiving. So only one cable, and you are sending 4 commands simultaneously at the same time. If it is not taken care in a buffer, if all are trying to send at the same time, then it will miss in the air, or it will miss in the cable, or somewhere it will be missed, and only one who is coming at the first, mostly the L1, because that is the first line in our code, L1, or in this sequence also L1, first guy is always wins in this race. So he is the only guy can reach to the motor, to the Quarky, and Quarky says, okay, I got L160. He don't know that L260, L360, they all got cancelled in the air or somewhere. It is not able to make out till him. And then finally, he is only sending the signal to L1, and he is only moving. And they all are not moving because Quarky don't know through the cable it not came. That's my hypothesis. But wait, then how their block is working? The block they are using, this block, it's working perfectly fine. Then what magic they did in this block, which we are not able to do here? Any guess? Just pause the video, think about a while, and then I will tell you my idea. It may not be correct. Again, you can write down in comment section if you have your different view. So the thing is, what I think, because all 4 are separate command passing through the cable, they are clashing, they are having all this problem. But what if you create a long but single command that has shell for each and every servo's position. So how many servos? Total 12 servo and a delay time. So all these 12 and 13. All these 13 parameters clubbed together, if you create a single command that goes atomically, I mean that goes without any break, without any middle interruption, directly through the cable or through the Wi-Fi here, and then he knows this is a composite command which has details for all the servo and how long I should take, and it has a separate imagine if else block, that if that command comes and I get all these 12 servos instruction and timer, then let me perform this setup code. So that setup code has already flushed through the upload firmware, and when because you upgraded the PictoBlox 9.1, the firmware also got updated. They have this extra code and this new block in this part. So this new block has a unique name along with all these parameters and the delay time, totally 13 parameters. And once this new if block added in the firmware receive this, he will do that processing and send command to all the 4 servo at the same time. Because understand this code is running inside your Quarky, and this block code is running inside your computer, and after that it is passing through the cable. So this passing through the UART or passing through the Bluetooth as a UART is a very costly operation. Otherwise your ESP32 or your laptop are very much capable of processing, sending these commands. Just the bottleneck is this UART communication. Hope you understood this point. Please write down in my comment section that if you have any other hypothesis, and if you think this is not conclusive what testing I did, and if you think there is a flaw, and then we should do some further testing to conclude or pinpoint where exactly the problem is, please write down in comment section. So this is just take it as a debugging class, and hope you enjoy it at least a little bit, because I know debuggings are boring for some time, because you didn't see anything really happening. It's just the dog was already moving, walking and doing everything good, and suddenly now you see he's just lying upside down and he's throwing his leg. That's not a interesting thing a kid will like, but maybe if you're an educator or a grown-up kid, then hope you would enjoy this video. With that, thank you for listening to me. Bye.